Process capability example D. Remember, if you would like to have a hard copy of what I'm showing you, you can go to the announcements and there are attachments, one for SPC charts and one for process capability that you can download. Alright, here it is. We're taking 4 measurements an hour, and let's jump on over to the answer sheet. Of course, we did our X bars and we did our X bar bars. Now I will throw this little bit of information in. It doesn't really impact you because you're still going to have to calculate the X bars, but if you were to just take the average of all these numbers at one time, you would come up with this number as well. It's called an unbiased estimator. So if you're doing this manually, you do not necessarily have to calculate each one individually. You could just say equals average of all these and it would come out to be that same number. But when we're doing the SPC charts anyway, you've already got the information. Why do it twice? Unless you want to double check yourself. Alright, moving along. Sigma, remember, equals STDEV dot S of these numbers. Don't include this, don't include that, and definitely don't include this. So there's your sigma. The CP is 30 minus 29, which is 1, divided by 6 times your sigma or standard deviation. So that gives us a CP of 3.01. And let's jump over here to CPKs. Remember, here's this, but we're going to take the lower of these two numbers as the actual CPK. So let's look at this one. We are going to use the 29.48 minus 29 and divide that by 3 times the standard deviation. And look at these numbers. They're very, very close to each other. Why? Well, because 29.48 is almost halfway between these two. So if it was actually 29.5, these numbers would be exactly the same. But since it's not quite, then they're a little bit different. And for this CPK for the upper, we're going to take 30 minus 29.8 and divide it by 3 times the standard deviation. We've done this 3 times already. This is the 4th time. So I'm going a little bit faster when I do this part. The key things are some of the explanations. That's why I'm creating 5 different versions. Is the process currently capable of producing parts? Yes. The CPK is sufficient at 2.89. To meet specifications, the CPK needed to be at least 1.0. Having a CPK of at least 1.33 provides a little more room for process variability. Different operators, different days, different different materials, whatever. So there I threw my thing in about that. And it says, if the process was perfectly centered within the specifications, would it be capable of producing parts? Well, it was already capable already, but we're going to answer that yes. The CP value is the measure of how our process would perform if it was perfectly centered in the middle of the specs, which it pretty much was. In our case, the CP equals 2.89, which is much more than the needed minimum of 1.0 needed to produce all parts to spec. So very good and capable process. What happens if the specifications were double? We just take the CP and we double it like we did in ABC. And what happens if we would like to have a CP of 1.0 on both sides? Well, guess what? We could do that if we changed the tolerance. Remember we said we're going to do the X, remember these numbers? The X bar minus 1 times 3 times the standard deviation we calculated, or the sigma. And we come up with that number. And when we do the upper spec limit, we're going to use X bar plus the 1 desired CPK times 3 times the standard deviation. And remember that our specification was 29 to 30. So to have a CPK of 1.0, we could actually have a tighter specification than what the engineering people gave us. And in a similar vein, what happens if we wanted to have a CPK of 1.33? Well, we would just plug in x bar minus 1.33 times 3 times standard deviation, as well as x bar plus 1.33 times 3 times standard deviation. And you have that. And remember, if I change the CPK to, I want a CPK of 2, guess what? The distance from this to this is going to be greater. If I change the CPK to a 5, the distance between here and here will be greater, because you're basically, expanding your specifications as you do it. But we really don't always change our specifications, because the engineers oftentimes have a specific reason for setting a specification like they did. So